Assalamu alaikum. My name is Yahya Abshir Jama, and my metric is BE 190021. I am gonna present my parts. Introduction. Uh, Air project background. Referring to IE definition, power quality is concept of powering and grounding sensitive electronic equipment in the manner suitable for the equipment. In the power quality, there are many types of issues that can be identified. These include both overall voltage transistors and harmonic producing load. Transistors, or commonly known as surges, are sub cycles of disturbance of duration that vary greatly in magnitudes. B. Problem statement. Overall voltage transistors are short duration, high magnitude voltage peaks with the fast rising edges, commonly referring to as surges. Many causes that can lead to this problem, which includes latent streaks, power factor capacity switching, inductive lead switching, and automatic tap changes. C. Objectives. The objectives for this project are to build in a circuit in order for overall voltage transistor through the search resistors. Task 1, and the harmonic producing load be using Mccain filter in MATLAB software. Task 2, to simulate the power quality problem caused by overall voltage transisting through the search resistors. Uh, the scope. The scopes of this project are: the simulation is done using MATLAB software, simulating power quality related distributions from the circuit of power quality problem caused by overall voltage transistors through the circuits arrested task 1, and the other circuit by of harmonic producing load and mitigating filter design task 2. That's all my parts, and thank you so much.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Muhammad Abdullahi Awad. I'm a math number is PE 190015. I am group 5, uh, group project of course power quality. Tonight I would like you to present a part of group assignment. The part is literal review. First we are talking about harmonics. Harmonics is defined as a mathematical model of the real world. Harmonics are a technique to analyze the current drawn by computers, electronic ballast, variable frequency drives, and other equipment which have modern transformer less power supplies. There is a low electrical energy called Ohm's law, in which this law states that when we voltage applied across resistance, a current will flow. This is how electric equipment operates. And this figure shows us voltage waveform. The utilities play an important role of generating this voltage in sense wave. It has constant amplitude and constant frequency. Once the voltage is applied to a phase, Ohm's law is applied. Ohm's law states that current equals voltage divided by resistance. So expressed graphically, the current ends up being another sine wave. Since the resistance is a constant number, Ohm's law dictates that the frequency of the current wave is also 6 Hz. In the real world, this is true, although the two sine wave may not align perfectly. The current will indeed be a 6 Hz sine wave. Secondly, we are talking about transist. Transits are known as a poor quality disturbance that involve destructive high magnitude of current and voltage, or even both. It may receive thousands of volts and amperes Even in low voltage system, however, such phenomenon only exists in a very short duration for less than 50 nanoseconds to as long as 50 milliseconds. This is the shortest among power quality problems, hence its name transist usually include abnormal frequency with clock reach to as high of 5. So this is figure also show us waveform transist. In addition, transits are also known as surge. According to AE Hunterin, surge is a transistor wave of voltage, current, or power in electric circuit. Other IEE definitions suggest that it's a part of the change in a variable that disperses during transition from one steady state operating condition to another. So that's my part. Thank you.
Hi, my name is Subaka Amali binti Mahazi with metric number DE190193. I'm going to share about the methodology for this project. Based on the flowchart, we started by searching reference that related to the project. Then we designed the model and electrical schematic using MATLAB software. For task 1, we simulate the mitigating power quality problem that caused by overvoltage transient and proceed to task 2. But if the desired output is not satisfied, troubleshooting needs to be done by including the input parameters. Next, for the task 2, which is simulation of the harmonic producing load and mitigating filter. If the output is satisfied, the analysis of the output result can be made. However, if the output results are not satisfied, troubleshoot of the error or problem needs to be done again with the input parameters. Finally, when the satisfied output results are analyzed, the conclusion can be made. So, the project is considered as successful.
My name is Norman bin Senu, DE190173, and today I will continue with our discussion and analysis for our project. For the first project is the simulation of mitigating PQ problems caused by overvoltage transient. This is the simulated model that we propose for task 1, and this is the voltage and current during fault occur, and this one is the voltage and current during the fault clearing. So the comparison between the voltage at series arrestor and shunt connector arrestor. If you can see from here, the voltage through the arrestor will increase until the simulation time reach 0.1 second, while the voltage through shunt connector arrestor show its normal voltage until the simulation time reach 0.1 second after that. And from this graph, we can see that the current to arrestor normal until fault happen, and when the current reach its peak value, it will fluctuate until the simulation time reach 0.1 second. Now for the second task for our project, which is the simulation of harmonic producing load and mitigating filter. This is the block diagram that we use for our task 2, and from figure 7, it shows that the simulated result of the three-phase voltage and current between bus B1 and bus B2 with harmonic filter. We can observe that in the current, the value of B2 after the harmonic filter getting distorted due to the harmonics injected by the rectifier, which is the nonlinear load in this case. While figure 8 shows that the FFT reduced until 0.969, and from figure 9, this is the impedance versus the frequency of the harmonic filter with an alpha firing angle of 19 degree. Figure 10 is the DC voltage level output when the firing angle is set to 57 degree, and this is a comparison between the harmonics at bus 1 and bus 2. And the result for FFT analysis when the firing angle is set at 57 degree is this one, which is the THD is 1.11%. So this is the impedance versus frequency of the harmonic filter with an alpha firing angle of 57 degree. This is the DC voltage output level when the firing angle is set to 10 degree, and this is the comparison between the current flowing into bus B1 and bus B2. After we do the simulation, you can get the result for FFT analysis when the firing angle is set at 10 degree is 13.39%, and this is the impedance versus frequency of harmonic filter with an alpha firing angle of 10 degree. So that's all from me. Thank you.
In conclusion, this paper has explained about some of the power quality issues that can create power system which are of voltage, transit, and harmonics. It point out the cause for their respective power quality problem, the effect of power quality problem in cooling efficiency, overheating, and shortening shelf life of equipment, loss of data, process interrupt, insulation breakdown. It is not possible to eliminate the cause permanently, but there are some mitigations that can be done to the system in order to improve the power quality of the system. Thank you.